use. Good, you started that. What tools can I use? What tools should I use? What are some of the trends and tools? And then what can I do to kind of, get the ball rolling and do my own? So I'm going to be talking about several tools and methods, talk about what machine learning can do and how you can make that happen. All right, a little bit about me. One thing that I'm really happy that I came out with a book in August, so on cognitive services. So really kind of excited about that. All right, so we are going to be talking about what you can do with machine learning, steps to generate machine learning solutions, algorithm selection tools, and using different tools. So what is machine learning? Well, really, it's not as fancy as you might think, although, of course, I put a picture of a robot out there, but it's really the development of algorithms that are used to help make predictions with data. So it's fancy pattern matching, but you can use the algorithms to actually learn how to do things. So the goal with machine learning is you're actually teaching the computer how to make decisions based on the pattern that it sees with the data over time. And it's a branch of artificial intelligence, or artificial intelligence is a branch of machine learning. I've heard it go both ways. When you get into artificial intelligence, it tends to be a little bit more complicated than machine learning. It's a number of different machine learning things that you put together. And really, it's a lot of advanced data pattern matching, looking for answers in your data by changing your data and having algorithms pour through it, really. So a lot of people are talking about what they can do with machine learning and what kind of things they want to do with it. But really, and I find this important when I'm talking to clients, is you got to figure out if you can do, the first step of machine learning is, can you do what somebody thinks you can do? So there's really 5 questions machine learning can answer. Is there a relationship here? Is what if, like, you're looking perhaps for causality, you're looking for things which have a pattern and move together. For example, identifying which are your best customers. So looking at how they relate with the company, seeing if you can find a relationship there or not. Seeing if you can see things that move together or move in opposites, looking for trends, that sort of thing. Another thing you can do with machine learning is look for if there's something wrong. This is commonly known as anomaly detection, and I'm sure that everybody has experienced the card from the credit card company saying, we have detected that there may be something wrong with your account. That's machine learning. They comb through all the transactions that are going on and look for patterns that might indicate fraud. Recently, since I have had them call me, I can tell you that a current pattern is that somebody will charge something and then reverse it. And if they do that, like at a gas station, you'll probably get a call, because who reverses a charge at a gas station? Thieves. So basically, they're trying to look at patterns to see if there's something wrong. Another thing that you can do with machine learning is predict what will happen. So you're looking at data, you're looking at patterns, and you're like, well, these things tend to move together, so I can anticipate that this is going to happen in the future. I will say that a lot of this is based on things being the same over time. And what I found out in this past year is that many machine learning predictions have gone to hell in a handbasket because there's something called a unicorn event, which is COVID. And since people do not react the same way as they did, that it's very difficult to predict what will happen. As a matter of fact, I turned down a machine learning job in February of this year because I said that I didn't think that it was possible for me to do any kind of predictions. They were looking at loans, and I'm like, I can't look at your data and predict what people will do. Not really, not this year, because it's so up in the air. I don't think your results will be proven out over time. So that's one thing to think about when you're looking at predictions. But a lot of things that you can look at for that is trying to identify trends and things that tend to happen a lot over time. So maybe you can predict what will happen if there's another lockdown or, that sort of thing. But that's a lot of what machine learning is doing, is trying to predict, how the different variables will come together. Another thing is you're looking for is how things are organized. So do you have people that, or events that work in concert together? Just an example of how this might, what you might do is, I was had a client a couple of years ago, and what they wanted to know is, what was the impact of an Amazon bad review on customer sales? Because what they were going to do with that information, what they did do with that information, is that if they noticed that a bad customer review seriously impacted their sales on Amazon, they were going to hire 3 people full-time to handle any and all concerns on Amazon, because they were figuring that their salaries would be paid for by the increased business, because somebody was sure that this a 1-star review was going to impact sales that much. And honestly, what I found out was it did not have that big of an impact in sales, which is actually kind of surprising, but people figure there's at least one loser out there. So they determined that they didn't end up hiring anybody to fix their 1-star Amazon issues, because it didn't really matter. There wasn't that relationship there, or the organization there. And the other thing that you can do with that is determine what should you do next. And this is important when you're looking at something called regression analysis. If you're looking at things that are the big influencers, then you can determine what's important to focus upon, what areas are most important, and what ones are most likely to lead to substantial growth. So these are what you can do with machine learning, and the kinds of things that it can do. You'll notice that magic is not here. And I know people kind of think that it can be magic, that you can do all the things, but really you need to be focused on what the answers that you are trying to find out with data, because yes, all of these will take lots of data to be able to come up with answers, and you need to have that data in the right format to be able to do that. So what the first step in doing machine learning is data analysis. So, and this is something that you really don't need to do much more than SQL to be able to do. As a matter of fact, there's more time spent on data analysis than actually algorithm selection, which is the harder part. For example, one of the things that somebody contracted with me to do is, I was talking to a very large oil company, and they had pumping stations in very remote parts of the US. And they wanted to use machine learning to determine, based on their IoT data, when they would have a catastrophic failure for one of the pumps that they had in these remote areas. Funny enough, what they were telling me is that it wasn't so much the parts in maintenance that was the big cost, but they had to send somebody out. Generally, it was at least an overnight stay. Driving was involved. They had to bring a lot of parts with them because I'm not sure what they were going to use. Very people who are well trained, and it was very kind of logistically important to do all this kind of maintenance to make sure that the pumps didn't go down. So I said, all right, let me look at the data. Well, and they had like, oh, we have IoT data, so we'll be good. Well, I looked at their IoT data, and as commonly happens when you have a lot of IoT data, is people stop looking at it. And what they didn't realize is they only had data 4 times a day, which isn't enough for me to look at what's going on at a pumping station, like right now, or really to discover trends, because I only have 4 data points a day. But then the other thing that was kind of like the bigger, oh, by the way, which is why I did not end up doing this job, as I said, all right, can you give me an example or a set of data that shows when this pump failed? And they're like, well, we don't do that. Our pumps never fail because we do all this preventative maintenance. So they won't fail, because if they fail, it costs us a lot of money. So I had no data to record or to analyze for what happens when it about to go. So I couldn't do it. So a lot of times that's a big question. I had another client that I ended up turning down because what they wanted to know, it was for a regional bank, small bank, and they wanted to know what kind of products constituted were people had if they were likely to buy more. So they were looking at their customer base and they wanted to know, if you have this kind of account, are you likely to have this kind of account? And does our marketing that we've been doing move you in any given way? And I'm like, all right, well, how much data do you have? Oh, we got 18 years of data. Well, when I was looking at the data, I looked at the product table and I'm like, these all have pretty new dates. Like, oh yeah, we just changed all of our products last month. So I couldn't do the analysis because their products were all different. So I couldn't see how they were relating over time because they just made a new series of products with different features and functions, and there just wasn't enough data to do anything. So, you know, it's really important to do that kind of analysis because maybe you can't do what people want. And you have to be upfront and analyze the data to determine if it's possible. I always want you to do something. Whether or not you have the ability to do it, you know, hey, that's something you may or may not be able to do, you know, just based on what you have for data. The other thing with data is that you're going to need to have appropriately sized data sets. So you need, and the appropriate size depends, again, going back to what are you trying to do? If you are trying to look at things that go wrong, you need a lot of data. And the reason why is that things don't generally go wrong. Things tend to go right. And because things go right, you need to have a data that shows when they go wrong. Like, for example, I use my debit and my credit cards a lot. And I've only been called once this year. So, you know, all those other transactions, they were just fine. So you need a lot more data if you're doing something called anomaly detection than, say, if you are looking for trends of things that move together over time, or if you're trying to decide if the data is one of these things or another. And the reason that you need all this data is because you need to try different algorithms, and different algorithms need different data to make that work. So you're going to be doing a lot of data cleansing and organizing. For example, it's not good enough if you have data that is mostly good, but you got some nulls. So you're going to have to figure out what you're going to do if you have missing data. And I can tell you that generally speaking, that what you do if your data is missing is you got to throw out the record, because it starts to impact your ability to do anything if you've got a lot of missing data. Another kind of the organizing stuff that you will need to do is that algorithms tend to like data formatted in specific ways. Some of the ways that they like to see data organized is to, instead of having like categories, like if I have apple, banana, and pear in a column that says fruits, what the machine learning algorithms want is they'll want something where I pivot it, which is called one-hot encoding. And when I do that, I would then have a column that has a banana, that says banana, and I'd have a 0 or 1 in it, indicating if there was a banana, a pear, or an apple. So I'd have 0s and 1s instead of the names. Another thing that I might do, let's say that if I'm looking at analyzing data sets to determine what kind of price per square footage, say, I could get on houses that are being sold, I would probably take the home selling price. And let's say the lowest one was 250,000 and the highest one was 2 million. Instead of putting those numbers in there, at 250,000, I'd make that 0. And I would make the 2 million one to be a 1. And I'd have everything in the middle to be something between 0 and 1 proportionally, as it would be within that range, because algorithms have an easier time with numbers in that particular format. So those are kind of things that you might have to do to your data so that it will perform better. Take out nulls, reformat it so that it can work better within a machine learning algorithm. So there's a bunch of time sinks when it comes to developing machine learning solution. One of them, of course, is cleaning your data. And given the description that I just made about it, that's, you can kind of understand why that might be. Determining the best algorithms is also kind of hard, because the algorithms are what's used to teach the computer about your data. And there are so many of them that you could use. And then once you have decided which ones you want to use, then they have parameters that you can tune on top of that to make it perform even better and give you even better results. So these are all kind of iterative process to run the algorithm, tune it, and see if you can get a really good response. So that does take quite a bit of time. And the reason that the algorithm selection takes so long is there's so many different options that you could like, well, it could be this one, could be this one, could be this one. And they're broken down by the types, but there's different ways that you can use that. So you need a lot of data when you're running these so that you're not running the same data set over and over again, because that tends to skew your results. My favorite, and this is called overfitting. So overfitting, another example of what that is if you have overfitting is kind of like if you've ever studied for a test where you have the answer key. And so you know the answer is B. And after a while, and you don't want to do this, but it's just human nature and it's computer nature too. Instead of looking at reading the question and then reading the answer, you kind of like go, oh, here's the question, that's a C or that's an A. And the computer does the same things, which is why you need different data so that it doesn't figure out the patterns of what the answer is and just start looking at the patterns. Best example I've ever heard of this is that if you are also a Lord of the Rings fan, the entire battle scene with the orcs and the elves, the humans, all that is CGI. And they don't like draw the little pictures and have them fight each other. What they do is they have computer algorithms that actually, have them, shoot the arrows and beat each other with clubs, etc. And so they kept on using the same data set over and over again, because you're weighing the efficacy with certain weapons and certain orcs and certain elves and stuff like that. And they use the same data set so long that the orcs dropped their weapons and ran off because they knew they were going to lose. So you want to make sure that the orcs don't know that they're not going to win and use different data so that won't happen. So there's a bunch of tools that you can use to create machine learning solutions. In addition to notebooks, I didn't put it in here, but a common one is VS Code. And the reason that I didn't put that in there here separate from notebooks is because it does notebooks as well. So you could use VS Code if you wanted to use to write machine learning solutions. You don't have to use a fancy tool because, again, a notebook is based on a Jupyter notebook that was originally written for Python, but is now used in everything. Not only is machine learning using notebooks, but hey, you can use notebooks using Azure Data Studio as well and write your SQL with notebooks. So that's a very common tool that people use because you have the ability to look at the results in steps as well. As far as what code that you want to use to write machine learning, code of choice. I will say that your options can be very varied. You could do .NET, you could do Java, you could use Scala, you could use R, and you could use Python. I'm using Python, and the reason why is that it is becoming the most popular language according to something, a website that does a lot of contests called Kaggle. And Kaggle asks periodically, hey, what language are you using to write machine learning? And R, while it was really popular, it's got some limitations in terms of its architecture. So it can have performance issues. So it's not as high as it once was because it once was the bomb. Right now, the biggest tool that people are coding with, or library rather, is Spark, which is part of the Apache collective of all things Hadoop. And they support R, Python, Scala, and Java. And those are not coincidentally the ones that are most popular for using machine learning. I've chosen to use Python because it's the most popular language. It keeps on getting awards year after year. And I don't want to do another VB6, so where I get really good at a language that nobody cares about. So I'm using the language that was used to write YouTube of all things, which would be Python. As far as dedicated ML tools, there's a lot of those as well. There are some with Google, AWS, and there are also companies that create their own tools like DataRobot, H2O AI, and of course, cloud-based tools. And the reason that cloud-based tools are so popular is because a lot of this kind of analysis is very compute intensive. You don't see this so much now, but when I first starting with this, when everybody was using R, the people that got started really doing a lot of machine learning analysis with a lot of data were actuaries. And so they would run all this analysis on what the rate should be and what they could possibly expect for disasters in certain areas where they had a hurricane or something like that. And they would kick off a job on Friday and hope it didn't crash over the weekend so they could see the results on Monday, because some of this stuff is really intensive. Nobody wants to do that. Nobody wants to hog up their computer. So this is why the cloud-based tools have become so popular, because you can allow for infinite scaling of resources as long as you have infinite amount of money. You do not need to use a cloud-based tool. As a matter of fact, with Python, should you choose to do it, it's a free tool, and you can just download libraries, run everything locally, figure it out, and then figure out how you're going to implement a solution using it. But I will say that I tend to use cloud-based tools because that's what my clients want me to use. So I'm game. But I want to stress that you do not have to, but that is what I'm going to be showing today, because I wanted to give you an idea of where the more common industry trends are. So when you are looking at a machine learning solution, the big question is, well, how do I know if this is right? What do I know? Is this a good result? And really, to know the answer if this is a good result is you need to understand how the algorithms are judged to be useful. For example, if I'm looking at something called regression analysis, then I'm looking at remote mean square errors, looking at that value to determine how successful my algorithm is. And you can use graphical analysis. This is kind of useful, especially if you're doing something like cluster analysis, where you're looking for groups of things that go together. And of course, but you're probably going to want to look at numerical analysis to just see, yep, this one's good, this one's bad. I can tell that based on a number. And another thing that's really important to look at when you are doing a machine learning solution is what kind of influencers, what are the major components that swing it? Because people always want to know that. So, okay, I get that this is a good algorithm, but what are the most important of the data elements that if I change them, will change my results? What is the most impact? What variables have the most impact? What I'm showing here is I'm showing a graphical analysis that's used for classification algorithms. This is what's called a classic ROC curve. ROC curve is a dumb name. It stands for receiver operator characteristics. And what you're really looking for here is this diagonal line is a coin toss. And of course, you want to be better than a coin toss. So you want to get the highest curve above this line that you can possibly get. And what that is called is area under the rock. So it's basically, if I was to shade this line, this green area in here, this would be the area under the rock. Now, the goal that I want to have is I want to get a perfect one. And then golf, that's kind of like playing 18 holes and hitting the ball 18 times. Not probably going to happen, but that is always the goal. And then there's par. So we're going to be trying to get what we call par. So it's something below 1, which is going to be our area under the rock value that we're going to be evaluating. And the reason that I'm bringing that up is because we're going to be doing some classification algorithm running, and I wanted to let you know what will make a good score. So diving into algorithms, there's really kind of 5 basic ones that you can possibly look at. We're going to initially look at classification. We're also going to look at regression. Some of the other more common ones are anomaly detection. Again, that's finding errors. Time series, looking at predictions over time. And clustering, which is basically looking at relationships and seeing if you can determine what things relate. Similar to regression analysis, but it's a little more abstract. So there are a number of different tools that you can use when you're getting started with machine learning. There's some low code, no code ways of doing it, where you have the machine do the algorithms for you, and then you just run them and get the result out. And believe it or not, this is using tools is always a good thing. You don't necessarily have to write everything from scratch. Now, these tools are simplistic. They're not going to do the most advanced kind of analysis possible, but you can still get some really good results without having to do a lot of code to make that happen. And you can implement the results. There used to be a free tool that Microsoft had for doing this. Yeah, they discontinued it, so it's not free. But let's take a look at some ways of doing Azure ML, which is a way of getting a low code solution for machine learning. So it's really easy to create a machine learning instance. So I'm not going to bore you with how to do that. Suffice it to say that you will need to pick compute, and compute is, of course, where you're going to want to keep that where you have your data, and your clusters are separate from your compute. So your computer that you were running it on can change over time. So if I go ahead and launch Studio, I get into this environment here, which is where I can do a bunch of different machine learning analysis. Now, for those of you who are familiar with the way that Studio, if you've ever saw a tool that Microsoft called the Azure Studio ML, which was free, they discontinued that. Here is a great way of looking at the kinds of steps that you need to do for machine learning. So basically, you're going to have raw data. You're going to select those important variables. You're going to clean it. You're going to split the data into test and training. You're going to apply an algorithm, and you're going to train the model, and you are going to score the model. So this, if you choose to use this drag and drop way, this designer within Azure Machine Learning Studio, you can use this to generate code that you could actually implement. So it's clicky, clicky, draggy, draggy, but you can create a solution using this that you could implement in a web service. So it's not as cheesy as you might think. But what I wanted to show you with is something that's called automated ML, which is kind of a walkthrough that you can do and implement these results as well. And with this, what we're going to do is I'm going to take this bank data set. And if we take a look at the data, what we see is I've got a number of different information about my customers here. And then the last column I have here is whether or not the marketing that was provided resulted in them getting a new deposit account. So looking at all of these variables will help me determine, hey, are these people with these kinds of characteristics, are they likely to get a new deposit account? And the reason that I have data like this is because what I'm going to do is I'm going to take a new set of data after I've got this all trained up, and I am going to determine figure that they will work the same way, and then I'll mark it to the people that are likely to get a deposit account, because I know that they're based on this criteria, they're likely to sign up for one. So how can I do something simple like this, and how can I implement it? Well, first, of course, I need to have a data set, and I'm going to pick this data set to work with. And the next thing that I'm going to do is I am going to create a new experiment, and I'm going to call this classification, because I'm classifying yes or no on the deposit. And the target column is that column that I showed you, which is true or false, and that is the deposit, which is the last one. And with this particular tool, you don't have to do a whole lot of data cleansing, because it's smart enough to figure that out itself. It would be better if I had changed these from 0 to 1. I would have a little bit better result, but this tool will handle that for me. And I'm going to select the compute instance that I have already created, and I'm going to run on that instance. So then what I'm going to do is and it says, hey, this is classification, because you just have 0 or 1 that you're looking for. And I can say, okay, I'm going to do some additional configuration settings here. So I'm going to say that I'm looking for the best area under the curve score, that graph that we looked at. And my exit criterion is that how long is this going to run before it gives up? Well, I'm way too cheap to have it run 6 hours. But I really want to know is if you've got a 0.9, you're awesome. you can be done. So what this exit criteria is telling me that if the job runs an hour, or, whichever one's first, if the AOC score is above a 0.9, stop. And that's the algorithm that I'm going to use. So it's going to use machine learning to pick machine learning algorithms. And it's going to validate automatically. And concurrency is how much compute that it's going to use. So I'm going to go ahead and say, save this and finish. So it is creating a new run. It's going to run and it's going to find an algorithm for me. Now, I'm going to show you what I call the cooking school version of this. And basically, this is how I don't want to have you wait around for it to come up with a good algorithm. So we'll look at a previous example that I did to see how all that worked. So what I did, let's see. Yeah. This one, I did the exact same criteria and it finished running and it's looking for the AOC of 0.09 or greater. So let's take a look at what happened here. So what this did is it ran my experiment a number of times and it used different algorithms and it set its own hyperparameters. And when it got above a 0.09, it stopped. And the algorithm it selected was the scalar wrapper boost classifier. And I can get an explanation of this. It's going to provide me some information on it. And it's going to tell me, the important features. It says duration, outcome, contact, and month. So which month I do is pretty important. And I can see dependency plots here. And I can take a look. And so this is, I can take a look at, it doesn't have any snapshots. But I can see the data transformation that it did to clean this up. So I'm learning from what this did. And if I have a result that is a very good number, so I can go ahead and say deploy. And then I could put this as part of a machine learning pipeline using ADF and call it, or I could call this from within a website. And then I can use this run that I just created using an automated tool to find an algorithm for me and then pick the appropriate algorithm and run it. So kind of cool. I didn't have to know a whole lot, but I can also look at all the other metrics. These are the weighted accuracy, the balance accuracy, the F1 score, because there's of course more than one way to measure it. So I've got my model here, and I can go ahead and deploy this, and this is all it took to do that. All right, so that's the easiest way of doing machine learning. But one thing that you're going to notice that all machine learning counts on is it's using languages and libraries. So there's popular languages like R, Scala, and Python, and they all contain libraries that people use to build machine learning solutions. So nobody's creating their own algorithms, or at least very few people are. I will say that some reason that people are using R specifically is because they've created industry-specific libraries that they use to calculate results that are very improved over time. So that's why I see some people that are continuing to use R, because of the libraries that have been associated with it. But in terms of libraries that you can use to build solutions, you can use all kinds of different libraries. For example, shameless plug, since I wrote a cognitive services book, you can also call cognitive services to analyze, and use the libraries contained with it to analyze your data as well. So one of the things that cognitive services is a bunch of algorithms you might find useful, looking at sentiment analysis over text. For example, looking at key elements within text. Those are some of the things that you might want to use a cognitive services library for. And these libraries are designed to use with solution. Now, pretty much all the popular languages now are using Apache Spark. And Apache Spark is a way to run machine learning solutions faster, because it figured out how to do multi-threading processes better than other computing algorithms. So that's really what Spark is providing for you, is the ability to bust the problem up, put it in different places and come back together and give you an answer, which is why you see so much with Apache Spark. Many different, again, you could use R, .NET, Python, Scala to do Apache Spark. One tool that people are using a lot with machine learning and Apache Spark is Databricks. Databricks is a tool that was created by many of the people that wrote the first Apache Spark library. Apache Spark was originally created to help a bunch of Berkeley grad students in 2010 try to win a contest for picking the best Netflix algorithm. They lost, but they created a way of harnessing compute that later on became Apache Spark. So their loss was everybody else's gain. They didn't get the $1 million though. They weren't even close. So what Spark includes is it includes different libraries within it. Again, libraries are everything. And it uses, one of the components is Spark SQL, which as of Spark 3.0 is fully ANSI SQL. So you can do ANSI SQL against a data set of some kind and do analysis with that. It also contains, of course, a machine learning library that will allow you to harness these different computes, providing a number of different ways that you can go after an algorithm and figure it out. Stream processing will allow you to stream the different data elements if you're doing something with IoT or credit card transactions, something like that. And GraphX is used for relationship gathering. So let's take a look at doing machine learning with Apache Spark. So for that, what I'm going to show you is a notebook that I created. Not that one. And what this is doing is doing different algorithms to determine what, I thought I had this one already, what possible results that I could get for this particular algorithm. So this is not, low code or anything. This is all code. And this first section here is just me loading up a bunch of libraries, which is a common thing for using Apache Spark or other machine learning tools. What Spark differs from, say, R in that the libraries tend to all come from Anaconda, which is the most popular implementation of Spark. It contains a lot of different libraries. So you don't necessarily have to load them to your environment, but you can just call them. So I'm going to take a look. This is using the same bank marketing data set that we looked at. I'm going to pull it in from a data lake. Again, this is the same bank CSV. I just got fancy and put that into Azure. And what this is going to do, it's going to take a look at my data. I'm just playing around with it here, looking at the deposits. But unlike when I did the click and drag version, I'm going to pre-process the data to put it into a format that is more readily going to be accessible by the algorithm. So I'm telling the index label that it is the index label. I'm changing that to a number. And I'm putting those into an array. And so here's are all of the categorical columns, and here are the numerical columns. And I'm going to reformat those. And then I'm going to change my category features and make those into numbers. Then I'm going to create my separate data sets, the ones that I showed you in the drag and drop version, where I've got an 80-20 version, and then I'm doing a sample of it. So I have test and training data. And then I'm going to run a logistic regression algorithm, because I got to pick something, to determine if that is going to provide me a good prediction. And after that, creating a confusion metrics to see my different area under the rock and other statistics are. And then I'm going to try to tune my hyperparameters and then validate it. And then I'm going to get some new data for testing. and take a look at doing another algorithm with the same data set using multi-class evaluation, seeing if I can improve my results. And then I'm also, after that, going to take a look at using binary classification metrics and then tuning those hyperparameters, trying the random forest algorithm, looking at those results, tuning those hyperparameters. And I'm doing all of this, which it will finish running eventually, so that I can find the best possible results for my machine learning solution. So this is really the kind of thing that I would actually probably write for somebody more than doing a tool. However, the tools have gotten pretty good. So I might not go to all this effort just to run 4 different algorithms. I might look at automating my tool selection, since so many of these tools now exist. So there's a number of different tools that you can use for algorithm selection. Data Robot is one of them. A friend of mine who used to work at Microsoft worked there for a while. They've got a lot of ways of ingesting your data and suggesting to you what the appropriate algorithm is. H2O AI does something very similar where they're doing algorithm selections. This is like a big trend in the industry to try to get the machine learning to pick the machine learning algorithm, which is a great starting point for people, so that you don't have to do what I just showed you, where you're writing a ton of code, doing a lot of evaluations to seeing if you can get the best possible results on your code. So of course, Microsoft is nothing but in league with the industry. So they have the Azure AutoML libraries that will allow you to do in code similar to what we saw in the AutoML version. So we've got actual code that we can write, kind of a medium between just click through a little visual tool and what I just showed you, where I wrote a bunch of Python code. So with that, what I'm going to do is I'm going to basically use these ML libraries to write this kind of code. So let me go ahead and show you that. So, and I'm also doing that. I mean, happen to be doing this within Synapse, and because it contains a place to build Spark. It has Spark clusters in it. I could also do this same kind of code within Azure ML, but I kind of gotten used to doing a lot of stuff in Synapse, so I got a lot of code here already. So here what I'm doing is I'm looking to do regression analysis on a really large data set to see if somebody is likely to get a tip or not. So I'm going to read my data in, and I'm going to just take a look at one day, because I got a ton of data here. And this is the data that I'm going to be looking at. And I'm going to take a further knockdown sample of that, just taking a random sample of that, which also provides me the ability to do more tests because I'm just doing a random set of data. So I'm also going to take out some features that I don't care about, PU, location ID, etc. So I'm only going to be looking at this particular set of elements from within my data set. So the vendor ID, passenger count, trip distance, it's got start and end lat long, payment type, fair amount, tip, the month, the hour of the day of month, and the trip time. So I'm going to go ahead and split my data into my test and training data sets and doing an 80-20 split. And then I'm randomizing it with this 223 random seed number. And then what I'm going to do is I'm going to leverage Azure ML to do its magic. So I need to have that resource already created so that I can call it from within here, which is what this particular call is. Note, this is my Azure ML code here that I'm running. And I'm just going to take a look at a training data set here that I'm going to be playing around with. And then I'm going to do some settings. Now I'm going to time out after 30 minutes. I don't want this to run forever. I'm going to run 4 concurrent iterations. And since I'm doing regression analysis, the score that I care about is my R2 score. So I'm looking at the best R2 score that I can get. So what I'm going to do, and if I'm going to log my errors, and then I'm going to submit my run. So it's going ahead and running it to find what the best algorithm is. So if we can look at that here, and it's going to show that the run completed. And we can take a look at, it said that the scores, no scores improved over 20 iterations. So it stopped early. So I made sure that I didn't want this to run forever. I got a pretty good R2 score. You can see here that I got the I did not set a value for this that I wanted. I just said I wanted the highest one. And they basically ran until they couldn't get it any better. And the best algorithm that I ran was this voting ensemble. But this is kind of a different, I use different parameters in this. And you can see that this does have the highest R2 score, but you can also see that I tried a whole bunch of different algorithms. And the reason that these two are the same, or these three rather, is that what the machine learning algorithm did is played around with the hyperparameters to see if it could improve the score. And it tried that 3 times and then it just blew it off and went with another one. But you can see that my different algorithms resulted in widely different scores. I mean, I've got everything from a 0.5 to a 0.97. And this ran in in 30 minutes because that was my limit that I set on it. And there's no way that I could have written this much code and have it run in the same time frame that I could do with this. So this is again getting it to pick the right algorithm for me. I might actually use this for pre-processing and then do some additional algorithm processing after this. Or I might just say, you know, I want to deploy this. And I can go ahead and click on deploy, and it will create a usable URL that I could use for calling from a web page. I could create put this into like a Kubernetes container and then call this from within an ADL pipeline. Got a number of different ways that I could use this particular machine learning component to get results at it over time. And I did this, you know, similar to, it uses this little library that is similar to that click and drag function, but I can just do this within code. So I feel a little bit smarter by doing that. So with that, that's pretty much, all I had to talk about today. We looked at what machine learning does. We looked at steps to generate machine learning solutions. We looked at how you can do algorithm selection. We looked at a number of different tools that you could possibly use to do machine learning. And then we took a look at how these different tools work. So you get an idea of what they can do and what you can do with machine learning. And with that, does anybody have any questions? I don't see any in chat.
And you may be on mute, so you may have to unmute yourself to chat or to speak.
Or you can type, and you can mute and type if you'd like.
No, Ginger, I thought it was a great overview. There's definitely a lot more that you can do with it, that's for sure. But this is a great introduction to it.
Thank you.
And you make it look so simple. I'll have to rewatch this a few times to absorb everything. It was awesome.
Well, I will say that the auto stuff is really that easy. The biggest thing to remember is when to make the sucker stop. And you can use those as solutions that you can deploy. So if you're looking to analyze data and you can come up with a question that is a classification problem, or you're looking at regression, you can come up with a very valid solution.
You're talking about all those clickety things?
Yeah, the clickety things. Well, thanks, Rose. But yeah, so one of the things too is that, like, I know people are like, you know, using it. So I wish that Reeves was here because he's more fun to pick on when he's available. He's my favorite foil because Reeves has a degree in math. And he thinks that, you know, you have to know a whole lot to like be able to do machine learning because you really have to understand the algorithms. I maintain that the computer can know the algorithms better than a human can pick them faster. Now, is this the end for a data scientist? No, it's not, but it can be a really good way to start a problem by knowing that you have the right solution. Because, I mean, look at this, there's a giant list of algorithms. Well, what if I skipped one and that was like the best one ever? So, and there's so many that are possible for me to pick because there's so many different libraries. So,
True.
Hey, so when you were in early on in the demos, you deployed, or there was an option to deploy. So does that essentially create an API endpoint that then you would access or call?
REST API endpoint.
Yep. Okay. Got it.
And you can implement that from anywhere. You could actually call that from within SQL Server.
Nice.
So there's a number, you can deploy it, you know, in many different ways. I know that Anna has a demo where she took a machine learning component and called it from within SQL that I remember seeing a while back. But because you could put this in part of a nightly process too that you might have with a SSIS or EF pipeline, so that it's part of its data processing as it formats the data. It inputs it into machine learning, then you can analyze the results that way that you might want to do on a nightly basis.
Yep.
So it doesn't have to be a one-off.
Awesome.
Any other questions? Well, if you can't think of any, feel free to hit me up on Twitter. I'm on there way too much.
So I did post a link to Ginger's book, the Cognitive Services, Beginning Cognitive Services, and check it out. Yeah,
one thing I will say that this is in the book that I'll just give you as a freebie is that in the late 90s, there was this study done from a bunch of veterinarians in New York City. And they, based on the cats that they had seen, they determined that there was a greater chance of a cat falling off of a higher floor window and surviving than a cat that fell off like a 1 or 2 story window. And people go, wow, that's amazing. Well, a couple of people who know something about data went and looked at that and said, well, that's because nobody brings a dead cat to the vet. So think about that when you're analyzing.
That's a good point.
Make sure that you have a valid set of data because you're not excluding things that people don't ever do. Like nobody brings a dead cat to the vet.
Point.
True story too.
That's funny.
I do have one quick question for you. If someone wanted to get an idea for or a better understanding of the principles of machine learning, what would you recommend?
Principles of machine learning. You know, I'm looking at my bookshelf right now, and to be honest, I don't like any of the books particularly that I have. There's a guy by the name of Jason who has a mastering machine learning. And his stuff is, I can't remember, I know another Jason, right? But he's I can't remember the guy's name, but he's got a series of machine learning master classes. I will also say that DataCamp is a pretty good place. They've got a lot of courseware that's like not like Udemy, so which most of sucks. That would be a good place to get a starter for just understanding the concepts of behind machine learning, which that's one thing that I really like about the visual tools, because if you get the steps down, then it's just a matter of what you're going to use to code them.
All right. So. Yeah, I was thinking something that wasn't so specific to a particular tool, but just to understand the concepts.
Yeah, I don't have a good resources. I have some that are kind of a whole bunch that are kind of meh, so that I don't really like.
Okay, thanks.
I think you need to start like Guy in the Cube, maybe Girl on an Island or something. Or I think, I don't know.
Just I like that a lot. I might use that.
Put together the way you just share your knowledge. I absorb it fairly well. and maybe it's just me, but I don't think so, right? But I think you're doing extremely well of articulating and communicating challenging topics in a meaningful and easy to consume manner. So I don't know. I have a think about that. So
yeah, no, I like that. Yeah, because I think is a lot of people do a lot of really advanced topics, and it's very difficult to get to where they are sometimes.
right. Yep. Hey, Leslie.
Can I second what Mark said, and Ginger, maybe you should write a book.
You know what's funny is that I, having done the last book, I was talking, because I'm such a sucker, I was talking to somebody about writing, and I will do it again because I want to do it on Amazon, because there's a lot of really great tools for doing it, and then I wouldn't be constrained by my publisher, who, let's just say, I don't think added a ton of value.
Well, I would read it.
Well, thank you. Yeah, it wouldn't be very long, because I've heard that nobody reads really long books, and me too.
Well, that's funny because I'm working on a book right now, and I keep being told that it's not big enough.
You have a publisher, right?
Yeah.
Yeah, there you go.
They must get paid by the page or something.
Yeah, they want what they want, and yeah, everybody's entitled to opinion. I'm not entitled to think everyone's is right.
True.
So Leslie has a question. Leslie, you want to share your question? You're on mute.
You're still on mute. We take her off. We have that kind of power.
Now, I have
there
a
you go.
totally unrelated topic. I do not want to be rude and get off topic at all. I mean, I want to be considerate.
Go for it.
Is okay. So this group is mainly out of Denver, right?
Yes.
Okay. So I work at Front Range Community College, and we are looking to get feedback from industry about our programs and how they can be improved, or they can be, if they're up to date. Particularly, we are looking at what tools are being used in industry as front ends for SQL. But that isn't all. And so anyway, and I know that Access could be one of those tools, and we do teach Access. I teach it, and it's fine. But anyway, we're looking for feedback. And so if anyone has any feedback of, one of the tools that are commonly used for front-ending SQL server databases, or anything, or any other topic, I'm going to put my email in the chat. And if you have any thoughts on it, I would totally welcome it. And thank you very much for allowing me to have this moment to express this. And I don't want to interrupt anymore.
No, it's a great topic, because I think I'm really interested in like mentoring and helping people get started. And I feel bad for people that do programs that are not terribly useful. And I actually have a friend who does this for a living. He's a computer science guy out of LA, and he consults with a lot of colleges on how they can improve and make their programs more real world. So it's great that the Front Range Community College is also doing this.
Mm-hmm.
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 So with that, if there's nothing else, I know that Todd's got a Dune movie to go see.
Yeah. Yeah. Sometime, Ginger, we got to have a conversation. I too